Welcome to NYNJPA Weather Educational Videos. Welcome back to another NYNJPA Weather Education video. Today we're going to talk about models and exactly how to tell when a model is actually doing well and when it's, well, not doing so well. So this is the GFS model guidance, and today we're going to talk about where to find the models and, well, the most basic models and how to determine whether they're doing well. And also a little chat about, well, quite frankly, you're going to make mistakes as a meteorologist. Everyone will. So let's start off with that first, okay? Understand forecasting the weather is one of the most difficult processes in science that you could have. You're dealing with chaos theory, which basically means anything can and will happen. We still don't have the best understanding of everything that happens in the atmosphere. And believe me, if you are a young meteorologist or you're just starting to learn how to forecast, you will make mistakes. There are veterans who are at this for over 60 years who still make mistakes. The key, though, is to A, recognize the mistake, and B, learn from it. So today we're going to talk about model guidance. Now, where can we find the models? Well, that's a great question. Very simply, you can go right to the National Weather Service. That's right, the National Weather Service, basically www.weather.gov, not only has a lot of forecasts from professional meteorologists from the government, but they also have links for models. So what you do, you scroll down here, and you see right here it says forecast models. Now, the great thing about this page is that not only do you have model guidance, but you also have observations and analysis, and you also have tropical guidance. Right now, we're going to focus on regular model guidance, and then we're going to look at the observations. So, we'll go with the GFS model guidance for this particular setup. Actually, you know what? Let's do NAM model guidance, because I know that's completely out. So, first you hit on NAM, and then you say North America, because that's where we live. And we're going to do the latest model guidance at 12Z. And we're going to, for this example, we're going to use the 4-panel chart, but you can also use the surface. You can use 200 millibars, 250 millibars. You can break it down various levels of the atmosphere that are 925 millibars. This is really important in the winter, by the way. This parameter right here, 925 millibar temperatures and the 850 millibar temperatures. So there's different aspects to take a look at. So let's take a look at a very basic chart here. 500 millibars. Now you see that 0 and 03 and 06. This is really important. 0 is your initialization, and in this case is at 12Z, which in this case is about 7 a.m. Then it takes 3 hours beyond that, and then 6 hours beyond that, and so on and so forth. So you go from 0 all the way out to 84 hours with the NAM model guidance. The GFS model guidance goes all the way out to 384 hours. Note to future meteorologists, you never want to trust the GFS model guidance past 180 hours, let alone 384 hours. And that has to do with resolution and the capability of the model guidance and so on and so forth. We'll get to that at a different time. So how do I know that this is right? How do I know when I go back here and I decide to, let's say I'm going to loop the simulated radar. Okay, and we have the simulated radar, we loop it, and we take a look at it, and it's loading, and okay, how do I know this is correct? Do I just assume it's correcting? Do I just go to any of the forums and say, gee, everyone else must agree with it, therefore I should? Well, you could do that, and you could end up being wrong. The best way to figure out how well a model is doing is take a look at the initial observations, compare that to the way the model is handling those observations, and then usually you want to wait about 3 to 6 hours after the model comes out to see how well the model is doing the first 3 to 6 hours. Why? Well, if the model is having a hard time forecasting out to 3 hours or 6 hours, and there's a lot of error, the potential for more error to basically grow and just explode increases significantly as you move further out, which kind of makes sense. So here we have, in the case of simulated radar, you see all this precipitation developing over here in the Gulf Coast, and you see this storm developing nicely over the Pacific Northwest, and here's our coastal storm that missed, and it's lifting out into the Atlantic. So when we take a look at the observations, we'll go to the initial observation, and what you could do is take a look at the observations and see how well it's performing. So let's go back to the 4-hour window. There we go. So here we are. We have 500 millibars. We have a 1,000 to 500 millibar thickness. We have 850 millibar temperatures and the heights, and you have 700 millibars with the moisture. All right, this is the relative humidity at 700 millibars. So we have these variety of different selections to look at. So how do I know it's right? Well, first thing you could do is go back to the National Weather Service once again, go to forecast models again, and I'm going through this so that way you know you can find it yourself. This isn't some mystic crystal ball that only meteorologists can find. This can be found anywhere. The key to a good meteorologist is not how many models he can get to, but how well he could take the data that is free, by the way, for everybody, and look at it and break it down and forecast it properly. And again, there's nothing wrong with being wrong. Just admit it and then learn from it. Write it down. I have a book that's going back since I was about 13 years old. And believe me, it has plenty of errors in it. And the key point is that I learned from those errors. I said, okay, this snowstorm did X, Y, and Z. I should have saw this. Therefore, next time I see the same situation, I don't make the same mistake. So going back to the observations, we have upper air, we have skew T, which I'll show in a minute. This is surface data. Okay, now when we click on the surface data, let's say we're focusing on the Mid-Atlantic. Or do I want to do, let's see. Here we go. Perfect. So we're going to take a look at surface parameters. You have 10 millibar winds, 2 meter dew points, and 2 meter temperatures. Let's take a look at the winds. Okay, now this is the winds for, let's say, North Carolina. If I'm forecasting for North Carolina, I'm looking at the hour in which this is put out, and what I want to do is go back and compare it to the model guidance I have in front of me. So then what I would do is go to that model and say, oh look, there's a 10 millibar wind. And 6 hours out, how well does it perform? Well, the NAM is performing rather well in this situation. A lot of areas are having light and variable winds, and you can see that also with the model guidance. Okay, your strongest winds are towards the coast, and that's exactly what's happening on the observations. So 6 hours out from the start of the model to the current observations, the model is performing very well. Let's say you want to focus on New Jersey. Let's go back. We'll do Mid-Atlantic. And we'll do 2 meter temperatures. And again, all this is free. Here we are in good old New Jersey. And the great thing about the observations from the National Weather Service is that they have all the counties, you can get the towns, so on and so forth. So you never have to worry about there not being enough data. So that's a great thing about the National Weather Service right there. And you can see there's the temperatures, surface temperatures, and why is this important? Well, if you're forecasting for a winter event, and let's say the surface temperatures are warmer than what's being forecasted, and the dew points are higher than what's being forecasted, you might want to consider changing your snow forecast then. Because let's say if you're forecasting the temperatures to be in the 30s right now, and they end up being right now in the 40s, about a 6-degree error, that might be an issue for you. Again, a simple way of seeing whether a model is quote-unquote doing well or not. All right. Now, again, I want to stress that I see a lot of people out there saying, well, the NAM is doing this. And because the NAM is saying, or because the European model is saying X, Y, Z, this is going to happen. Weather is not controlled by these models. And I see this kind of voodoo running around of King Euro or GFS is doing this, or, you know, a lot of these assumptions that the models almost act like as if they're controlling the weather. Models change based on what's being put into them. And this is why we're doing this whole exercise. In that, if you know what's being put into these models, and you could see in the observations here what exactly is going on, then you could pick out the errors. Now let's go to upper level, because this is where it gets really interesting. Now this is North America, and let's say we're going to do 250 millibars. Why am I pulling this up? Well, we'll go back to our 4 panel here. Let's go to the GFS. Okay, we'll do North America. And we'll pull up 200 millibars. And say 6 hours out. Okay. And I'm taking my time doing this, that way you could see how easy it is to find this data. Very easy, trust me. Okay, so here we are at 200 millibars, 6 hours out from the forecast for this afternoon. And let's compare this forecast, where we have winds at about 110 to 130 knots, right into the Pacific Northwest. How well is that forecasted? Well, in this case, it's forecasted very well. As you can see, this triangle here means 50, 60, 70, 80, 90. Here we have another one, 50, 100, 110. Another 130. Here's another 130. It matches up very well, and that's what this means, by the way. Let me just go over this real fast. Each one of these triangles is 50, so it's 50, 100, 110, 120. Okay? That's how you read that. If it's only one, it's 50, and then this half one is 5, so that's 55. This is 50 right here. And then the fill-in circles here, that means it's overcast. Okay, so it's very simple to read these. So why did I bring that up? Okay, well, let's look at the models. What is the model doing? Well, it's the same thing. See, so the jet streak that's forecasted here by the GFS model guides, and granted, this is an easy forecast. I wanted to pick an easy one to kind of lead you into here. If you could match up the observations to the forecast, then you're dealing with a model that's performing reasonably well. Now, as you move forward in time, there are certain laws in meteorological physics that you'll learn to say, okay, the model made an error here. So, for example, prime example, you see this disturbance here, right? And you see this disturbance here. Let's say that this was a strong upper level low and this was an equally strong upper level low. And we've seen this before, where the GFS model guidance, for example, tries to phase every disturbance, or what should I say, put together, kind of like Plato, trying to put together everything into one huge upper level low. Physically, that is very rare in happening, and quite frankly, it usually does it in such a way that would defy the laws of physics, or defy the law of mass and conservation of mass. Okay, so these laws that you're going to learn later on as you go into college, which I could explain, but this video would be about 4 hours long, basically tells us whether or not the models are doing well or not. But for the beginner, just take a look at the observations here and see how well they match up. Now, let's do another one that's pretty easy. Let's go to 850 millibar temperatures. So we go back to 850 millibar temperatures. And let's see here. Now, the model guidance is suggesting that it is going to be around, let's see, 9 degrees Celsius around the Philadelphia and New York City metropolitan area. Where are we now? Right around 10, 9, 10, 11. Right about where we were forecasted to be. So as you can see, in this case, the 850 millibar temperatures are actually forecasted very well. And because of that, we can take, some liberties in saying that the GFS model guidance 6 to 12 hours out is performing very well. Now, that doesn't mean it's going to perform well all the way out to 240 hours. You have to, again, pick out some details that, hey, this doesn't look physically correct, so on and so forth. But if you can get the initialization of the data done correctly, more times than not, the model is going to perform very well. Every model has this little error and little issues. For example, the European model guidance, when it has a disturbance coming out of the southwest, doesn't always perform very well because of a lack of data down here. The GFS model guidance has a major problem with Arctic disturbances coming down south because of a lack of data there and a reduction in, I guess you'd call it resolution, which, by the way, they've improved this year. So it should be interesting to see how that works out for this winter. And again, this goes back again to taking a look at how the models are performing compared to the observations. This is another tool you can use. This is called the Water Vapor Satellite Picture. Again, very easy to find. You can go to Google and just type in NOAA Satellite and Information Service, and you'll be able to find this very easily. Now, this is the Water Vapor Satellite Picture. Again, you can see this nice deep trough, which matches up very well with the initialization of the model guidance here. Let's zoom out here. So you can see it matches up very well. What I like to do with the European model guidance is try to find these little disturbances, and they're usually pretty easy to find when you're looking at the water vapor satellite picture. You can see one disturbance here, and you can tell it by the disturbances by the light colors and the dark colors. Rising air, sinking air. You see the same thing out here in the Pacific Northwest. That's one heck of a nice disturbance out here. Here's another one that's pretty obvious, with that nice little curlicue right there. And here's our ocean storm that's developing nicely, and it's remaining well to the east, and it's being pushed to the east by all this driving into the west coast, this strong disturbance, which again matches up very nicely to the model guidance we have in place. So when we take a look at all this observational data, before you start diving into the forecast, then you can start to say, okay, this model is performing well, this one isn't. And then you can start to use that model that's performing the best, whether it's the European, could be both of them. Could be European GFS, you kind of merge both solutions, kind of find something in between that works out well. And then you go from there with your forecast. And finally, I just want to also bring up the radar, most obvious part of the forecast here. Obviously, we have a lot of rain moving into the Pacific Northwest, which is supported by the model guidance. And also, you're starting to see showers and thunderstorms developing over the Gulf Coast and up into the Mississippi River Valley and towards the Tennessee River Valley, which also was shown very nicely by the NAM model guidance. So as you can see, the models this afternoon are performing rather well. Now, the last thing I want to show you is surface observations. And I just want to go back to obs and analysis. We'll go back here. And we have upper level. We're going to test something out. What is skew T, you might ask? North America. We're going to zoom this in. This is basically, what we're setting up here is a vertical view of the atmosphere. It would help out if it actually worked. So we'll use a different source. We'll go to Penn State EWOL website. Now this is another great free model site that you can go to. And we're going to look at the skew T charts. Let's see if we can find any that's worth looking at. And the reason why I want, here we go, perfect. The reason why I want to show this is because I think it's important for everyone to understand the vertical aspects of the atmosphere. Or I could just do it in another video. We'll see. Perfect. Okay, here we go. We'll do one that shows up very easily. Or not. Alright, I'll do that in another video. Didn't work out so well. That's okay. Sometimes your best laid plans, even if they worked earlier, don't always work out very well. So we'll go to the observations here. Again, this is the Penn State EWOL website. You can take the observations that you see here, compare them to what's being forecasted 6 hours out from the initialization of the model. And you can see today the models are doing very well with the pressure, with the winds. Just kind of zoom here on the observations here. This is your temperature, this is your dew point. The amount of black filled into this circle tells you the cloud cover. So this is overcast. This means that it's in the script. This means clear. We have clear skies. This is partly cloudy, let's say. It's about a fourth of the sky that is filled with clouds. And of course, this right here is the wind direction. So we have around Atlantic City right here, we have winds from the northwest at 5 miles per hour. So as you can see, we have a pressure of 1,017.3 millibars. So when you see the pressure here, okay, when it doesn't show any nines, okay, like let's say if this was 973, this would say 973. But if it's saying 117, well, obviously the pressure isn't 173 millibars, because that'd be a really, really bad storm. What this means is that you add a 10 onto there, and then you got 10, 17, 1017.3 millibars. Same thing here. So as you can see, it is high pressure and control, clear skies, and matches up very well to the model guidance in place. Well, I hope you enjoyed today's video. Next video, we're going to go over the skewed T-chart, because that's really important. That's going to be next week. And hopefully this time, I'll have it loaded properly this time. And we're also going to try to pull up and take a look at BuffKit, which is another source of model data to look at when you're forecasting, let's say, severe weather or lake effect snow. Well, that's the video for today. Thank you again for joining me. Of course, I'm your meteorologist, Stephen DiMartino. Follow these videos because I'm going to be educating everyone about how to forecast and all weather phenomena. And if you have something that you want to learn about in terms of meteorology, of course, send me an email at sdmartino@nynjpaweather.com, or just go to nynjpaweather.com and send me an email from there. Have a wonderful day. Stay safe out there.